10 machines that still run after 100 years. Ever wonder if anything built a century ago could still work today? Imagine using a machine older than your great-grandparents, and it still runs flawlessly. These aren't just relics, they're living, breathing proof that some engineering was built to last forever. 10. Heidelberg Printing Press, 1914 to present. At number 10 is the Heidelberg Windmill Printing Press. It revolutionized small-scale printing with its rotating paper gripper arm, perfectly synchronized with the platen to apply even pressure. Built in 1914, it could produce over 4,000 crisp impressions per hour, an impressive feat for the time. German precision engineering, solid cast iron frames, hardened steel gears, and vibration-resistant construction ensures many original presses still run today. Even with digital printing dominating the industry, these presses remain indispensable for specialty work like embossing, foil stamping, and die cutting. Some have logged tens of millions of impressions without major replacements. Maintained by skilled technicians worldwide, the Heidelberg press proves that well-built industrial machinery doesn't just last decades, it can thrive for over a century. 9. Corliss Steam Engine, 1878 to present. Next is Corliss Steam Engine. In Providence, Rhode Island, the Corliss Steam Engine, constructed in 1878, is still in operation. The engine was known to be revolutionary in valve design, George Corliss, which enhanced efficiency and wear reduction, enabling the factory to operate more and have minimal need of maintenance. This giant motor drove textile mills decades, and its cast iron frame and its precision bearings remain. It is now run by volunteers on low-pressure steam, and all the pistons, flywheels, and cranks work in exactly the same way as they did in the 19th century. Its rhythmic movement and mechanical buzz provide a glimpse into the Industrial Revolution of America, showing that good engineering could endure long after 100 years. 8 Tower Bridge Hydraulic System, 1894 to present. Next in the list is the London's iconic Tower Bridge, which hides a marvel of Victorian engineering, its original steam-powered hydraulic system. When the bridge opened, enormous bascules could lift for ships entirely through steam-driven pumps, pressurized water, and pistons. The system was later changed to an electro-hydraulic system in the 1970s, but the engineers did not change the original engines, accumulators, and control valves. The machinery is still in good condition and is sometimes used as demonstrations. The oil-lubricated bearings, rotating flywheels, and steel pistons that were designed to absorb constant load move as smoothly as in 1894. Over 130 years later, visitors can witness the same mechanical principles in action, an enduring link to the ingenuity of Queen Victoria's engineers. Tower Bridge's hydraulic heart beats still, a testament to precision and longevity. 7. Strasbourg Astronomical Clock, 1843 to present. At number 7 is Strasbourg Astronomical Clock. Inside Strasbourg Cathedral, the 1843 astronomical clock remains fully operational. Its intricate system displays solar and lunar positions, phases of the moon, eclipses, equinoxes, and the date of Easter. Jean-Baptiste created almost 100,000 parts in 30 years, such as the automata figures moving every hour. The massive lifts of counterweights are used weekly to power the display. The original gears and escapement are still in operation, despite a few replacements of bushing and pivots, connecting the 21st century audience with the genius of 19th century engineering. 6. Harwell Decatron Computer, which 1951 to present. Next is one of the oldest working a digital computer resides at Bletchley Park, the Harwell Decatron, nicknamed the Witch. Unlike modern computers, it's electromechanical, using thousands of relays, vacuum tubes, and Decatron counting tubes to perform calculations at roughly 1 edition per second. Built in 1951, it was a real-time computing marvel, storing data on punched paper tape. After decades in teaching roles and storage, engineers restored it fully by 2012. Today, it still calculates, with its relays clicking and Decatron lights spiraling orange. Visitors can watch operations just like scientists did in the 1950s. Over 70 years later, this room-sized computer proves early digital technology was engineered not just for novelty, but for longevity, combining precision, patience, and reliability. 5. 5. The Great Laxey Wheel, Lady Isabella, 1854 to present. Above Laxey village on the Isle of Man spins the Lady Isabella water wheel, built in 1854 to pump water from the Great Laxey mine. Measuring 72.5 feet in diameter and 6 feet wide, it powered rods and cranks extending 600 meters underground, all without fuel or electricity. Restorations in 1989 and 2022 replaced corroded iron and decayed timber, but the original mechanism remains intact. Tourists today watch it spin, powered solely by flowing water. Over 160 years after its construction, a marvel of Victorian engineering still doing exactly what it was designed to do. 4. Centennial Light Bulb, 1901 to present. Hanging in Livermore, California's Fire Station Number 6, the Centennial Light Bulb has been glowing almost continuously since 1901. Made by Shelby Electric Company, its thick carbon filament and hand-blown glass endure because it runs at only 4 watts, producing a dim, warm glow instead of scorching heat. Carefully moved during 1976 firehouse relocation, it avoided power interruptions and has survived minor outages. Verified by Guinness World Records and modern monitoring systems, it has logged over 1 million operational hours. The bulb is a living artifact, viewed online and in the adjacent museum. Over 120 years later, this humble invention proves that simplicity, quality materials, and careful engineering can literally keep a machine glowing forever. 3rd, Boulton and Watt Smethwick engine, 1779 to present. In the 3rd position in our list is the Boulton and Watt Smethwick engine in England, which was constructed in 1779. This is true. This steam engine is more than 240 years old. It was one of the earliest engines to use the separate condenser developed by James Watt, designed to pump water to the Birmingham Canal, and was much more efficient. The giant flywheel, piston, and beam are still in use with the original castings. It was carefully conserved and preserved and is now driven on low-pressure steam to show how it used to move in the late 18th century. This engine is a living miracle of the first steps of modern equipment, which demonstrates that accuracy in engineering and high-quality materials can literally withstand time. 2. James Watt Beam Engine, 1812 to present. Taking position number 2 in our list is the James Watt Beam Engine, a 200-year-old steam powerhouse at the London Museum of Water and Steam. Designed to pump water for London, its massive overhead beam and vertical piston system still operate flawlessly using the original cast iron components. Every valve, bearing, and linkage functions as it did in 1812, oiled and maintained by hand. Low-pressure steam allows museum engineers to demonstrate its motion for visitors, creating a hypnotic rhythm of rocking beams and rotating flywheels. 2 centuries of continuous operation, precision engineering, and thoughtful design make it the ultimate example of enduring machinery. It's not just old, it's living proof that truly great engineering never quits. 1. Voyager spacecraft, NASA. And finally, number 1, the Voyager spacecraft. Launched in 1977, Voyager 1 and Voyager 2 are still operating in deep space, over 15 billion miles from Earth, sending faint radio signals nearly 50 years later. Originally designed to last just 5 years, these twin spacecraft have far outlived expectations, continuing to gather and transmit data from interstellar space, the first human-made objects to leave the sun's magnetic bubble. Both Voyagers have scientific instruments, magnetometers, cosmic ray sensors, plasma sensors, cameras, 3 onboard computers, a 3.7-meter dish antenna, and a nuclear power source known as an RTG. The planetary mission of Voyager 1 was completed in 1980 and provided the first up-close photos of the storms of Jupiter. Voyager 2 was next to make the same journey, visiting Uranus and Neptune, the only spacecraft to do so, and then proceeded out into unexplored space. The famous pale blue dot photograph was captured in 1990 by Voyager 1 and depicted Earth as a small speck in the sunlight. The RTGs are still capable of producing sufficient power today to operate important instruments, albeit at only a fraction of their initial 470 watts. It requires almost a complete day to send the commands to the spacecraft, and the radio signal is weaker than a refrigerator light bulb, but the Deep Space Network can receive it. Constructed out of slide rules, analog and soldering irons, these Voyagers continue to explore, go beyond their intended use, and demonstrate that in fact human engineering can be a lifetime experience and beyond. If you liked the video, don't forget to like, share, and subscribe for more content like this. See you in next video.